let's start. So guys, I want to go over the important points quickly. You have to know that dynamics is concerned with bodies that are accelerated or they have acceleration, and that kinematics is the study of geometry, which is the displacement, the acceleration, the velocity, and it is the result of kinetics that we're gonna study later on, which is the study of the forces. Guys, did I record this session? Let me see. Oh, I think yes, I record. Yes. All right. And then, guys, you have to make sure that there is a difference between average speed and average velocity, and we're going to solve a problem about it. So the average speed is equal to the distance traveled over delta t, while the average velocity is equal to the displacement over delta t. And there is a difference, of course, between displacement and the distance traveled. And you have to know, guys, that a particle can have acceleration. I am at slide 18, all right? That a particle can have an acceleration even if it has at this instant 0 velocity. And guys, what matters for me, or what is the most important part in these important points, is that you should know that you have 4 main equations. The first one is V is equal to dx over dt, and this could be converted to integration. We're gonna see how. And that A is equal to dv over dt, and it's also equal to ds squared over dt squared. And the last one, which is independent of time, and that I have derived in one of the videos, is that ADS is equal to V over D, is equal to VD. All right. Now, how to choose between them, we're gonna see, guys. We're gonna see how to choose between them. But I want you to know that each of these 4 equations is a 3-variable equation, which means, guys, if I take the first one, how many variables do I have here? You can answer me on the chat. Yalla, guys. How many variables do I have here? V, yes, 3. Good, Hassan. V, S, yes, Abbas, there are 3. V, S, and T. I have 3 variables. This means, guys, I cannot solve for any of them if I can substitute one of them by an equation of one of these variables. Yeah, if I can't replace V or S or T with an equation in terms of one of these 3 variables, yani if I cannot convert this 3-variable equation to 2-variable equation, I can't solve it. So my objective, guys, is to convert one of these equations from 3-variable equation to 2-variable equation. Whenever I do this, I can solve. I can find the integration and then I can solve. All right. So this is my objective in this part of this chapter. You're gonna see how. What are the steps? Now, guys, what I want you to know is that in order to solve any problem, what you have to do first is to indicate O and S. If they are already indicated in the problem, you have to take them as the positive direction, which means, guys, if this particle is going downward, you can take S positive downward, all right? So you can indicate the positive direction. And of course, guys, what you should do, you have to take the positive direction with the motion. Motion downward, take it downward. If the motion is upward, take it upward. If the motion is to the right, take it to the right. If the motion is to the left, take it to the left. If you don't know what is the direction of the motion, you have to assume any positive direction of S, and then you can solve the problem. All right, guys? Then you have to know, guys, that let's say I took this positive direction. Then you have to know that if V is positive, then V should have this direction. If A is positive, then A should have this direction. If the motion is decelerated, A will be in the opposite direction. All right? So guys, make sure that you indicate in the first place what is your positive direction. Let's now start with this problem. It is example 12.1. Guys, ready? Okay. Okay, so let's start this problem. I have a car that is moving in a straight line, such that for a short time, its velocity is defined as v is equal to 0.9 t squared plus 0.6 t. So here, guys, I know the equation of v in terms of t. This equation will help me out in converting the 3-variable equation to 2-variable equation. But I have to choose which equation I should use. And what is the question? The question is to determine x position and acceleration when t is equal to 3 seconds. So I need to find the position s, the acceleration, when t is equal to 3 seconds, given s is equal to 0 and t is equal to 0. Guys, what do you think? Why, guys, this given is here? Why I should integrate s is equal to 0 and t is equal to 0? So where can I use it? Noor, integration of v. Yes, initial velocity. No, it's not the initial velocity, Batul. It is the initial position. You mean the initial position because this is s is equal to 0 and t is equal to 0. In the boundaries, correct, Radwan. Yes, you're right, Radwan. So guys, Jad is saying that I can now integrate from v from 0 to 3 seconds. Jad, we're going to talk about this later on. But what matters for me now is the answer of Radwan. Yes, Radwan, you're right. This is the boundary condition, all right? Because without boundary condition, I cannot solve for this problem. Remember, guys, I can do the integration. But if I want to do the integration, yes, perfect, Batul. I cannot get rid from the constant of integration unless I have the boundary condition. So that's all right? So guys, let's show all the equations that I can use to solve this problem. What are the equations? Basically, v is equal to ds over dt. This is the first equation. A is equal to dv over dt. This is the second equation. A is equal to t squared s over dt. This is the third equation. Over dt squared, sorry, this is the third equation. And the last one is v dv is equal to a ds. This is the fourth equation. What do you think, guys? What is the convenient equation to use from these equations? All right, so Batul is saying I should use the first one. V is equal to ds over dt. Yes, why? Because in fact, guys, this is a 3-variable equation, and I know the equation of v in terms of t. So if I substitute v by the equation in terms of t, I'm going to have an equation of how many variables? And what are these variables? 2. And they are s and t. Perfect, Hussein. All right? So guys, I have to use the first equation, v is equal to ds over dt, because in fact, if I use this equation and substitute v by its equation in terms of t, I can find, in fact, s in terms of t. And this is the question. It is to find the position. The first part of the question, of course, is to find the position, right? So, guys, I'm going to use the first equation. So this is, guys, the first step. I have to show all the equations, and I'm going to choose the equation that I can convert to 2-variable equation. Of course, I'm not going to use the second one because I don't have the equation of A. I'm not going to use the third one because I don't have the equation of A in terms of S or T. And I'm not going to use this equation because, in fact, if I substitute V with this equation, I'm going to have 4 variables, T, V, A, and ds, and S. All right, so what I'm going to do now is to use the first equation and convert it to 2-variable equation. So how can I do this? In fact, I'm going to substitute v by 0.9 t squared plus 0.16. All right, so this equation right here will be equal to ds over dt. Then this is the first step, guys. Now the second step is basically to do the separation of variables. Right? So the second step is to do the separation of variables. What does this mean? I should put all the variables that are similar to one side of the equal sign. For example, here I have an equation with respect to t. So what I'm going to do is to move this dt to this side, because in fact, guys, they have the same variable. So I should do a separation of variable, and this is what we did always when we have a differential equation. So what I'm going to do here is to do a separation of the variables. 0.9 t squared plus 0.6 t, sorry, 6t dt is equal to ds. So that's it, guys. Now what I'm gonna do is to make the integration. Perfect, Noor and Hussein. So now, guys, I'm gonna do the integration. But Hussein, you think that this integration should be between 0 and 3? All right? I'm not gonna do it in this way. You're gonna see why. So, guys, I'm gonna now change the color. Let's take the red color and do the integration here. All right? Now, what about this integration? I should make sure to put convenient boundary conditions at the boundary of this integration. So here, guys, since s is between 0 and t is equal to 0, so I'm gonna put this 0 here, and then this t here will be equal to 0. So guys, make sure that you are putting the corresponding boundary conditions. Now at the second boundary, guys, I have two ways. Either to put here s, and then here to put 3 seconds. So I'm gonna do the integration between 0 and 3 seconds, because in fact the question is to find the position at 3 seconds, and then I can find s directly. Or what I can do is to put here s and here t. Why, guys? If I do this, what kind of s I'm gonna have? What kind of s, guys, I'm gonna have? Is it a numerical value or general formula? Perfect, Hassan. So guys, yes, Hassan, at any time, yes, Hassan. So basically, guys, if I do this, if I do the integration of this equation between 0 and s and between 0 and t, I'm gonna have the equation of s for any time t, and then the last step will be to substitute this t by the 3 seconds, which is the question. All right, guys. So this is, guys, it's not better. In fact, I can use 3 seconds directly, and then I can find s for this 3 seconds as one numerical value. But using this method or using this way of integration, I can find the general formula of s. So that, guys, if I have another question to find s for different t, I can now find it directly because I have the equation of s. If not, if you do, guys, the integration between 0 and 3, then what you have to do if you're gonna find s for another t is to repeat the integration again. All right? So what I have to do is to find the general equation of s, and then I can substitute with any other t. Okay? So this is what I'm gonna do. So s will be equal to, of course, s minus 0. All right? If this 0 was a 3, then this should be s minus 3 or s minus 4. It depends on the initial boundary condition for s. So s here is equal to 0.9t3 over 3 plus 0.6t minus 0, which is this one. All right? Sorry, 0.6t squared over 2. All right? So it is, in fact, 0.3t cubic plus 0.3t squared. Now, guys, you can substitute t by 3 seconds in order to find s. What about the second part of the question, which is to find the acceleration? Which equation should I use? What do you think, guys? Is it the first, the second, the third, or the fourth equation? The second equation. Why, Sana, I should use the second equation? A is the derivative of v. And we have the equation of v. Perfect. Good answer. Right? This is because, guys, I know the equation of v with respect to time, so I can find a. Right? So it is the derivative of the velocity with respect to time. All right? So a is equal to dv over dt. I can do the derivative. Now here I don't use any boundary conditions because I don't need them. This is the derivative. It's not an integration, and I can find a and then finally substitute, and I can find a in terms of t and finally substitute t by 3 seconds. All right? So guys, of course, as I said, if you do the integration between 0 and 3 seconds for time, you're going to have s directly as 10.8. But if you do it this way, guys, you're going to find the equation of s as the general equation in terms of t, so that if you have any other question to find s with respect to another t, you can directly substitute t by the value, right? You don't have to repeat the integration. And this is, of course, the answer of